All right, get ready to power up that knowledge base because today we're diving into the world of cutting-edge exoskeletons.
Yes.
Specifically, a revolutionary knee exoskeleton designed to redefine what's possible in terms of strength and endurance.
Right.
Particularly when it comes to lifting.
Yeah, and this isn't just about, like, augmenting human strength for the sake of it, you know?
Right.
This deep dive centers around a recent study published in Science Robotics that delves into a new breed of knee exoskeleton aimed at minimizing fatigue
Okay.
in those crucial quadriceps muscles.
You know those muscles that scream at you after a heavy leg day?
Yeah.
Yeah, those are the ones.
Yeah.
But why focus on the quads?
So they're the workhorses of so many movements: walking, running, climbing stairs, carrying heavy objects. They're constantly engaged.
Right.
And when they fatigue, it's not just about, like, feeling tired. It's a major risk factor for injuries, especially in physically demanding jobs.
Okay, so we're talking about reducing workplace injuries, boosting productivity. But this isn't some, like, off-the-shelf solution you'd find at a pharmacy.
Right.
This is cutting-edge tech specifically engineered to provide what the researchers call versatile assistance to the quadriceps.
Yes.
What does that even mean? Versatile assistant?
So it means this exoskeleton is designed to adapt to a range of tasks,
Okay.
whether you're walking on flat ground, climbing stairs, or hoisting heavy boxes. And here's where the engineering gets really impressive.
Okay.
It's back-drivable.
Back drivable. Now, I'm picturing some sort of reverse gear on a car.
Okay.
Break it down for us.
Essentially, it means this exoskeleton moves seamlessly with your natural movements.
Okay.
It doesn't fight against you or feel clunky.
Got it.
This is achieved using a specific type of actuator called a series elastic actuator, which is designed to provide assistance without impeding your natural range of motion.
Okay.
And this is crucial because in a workplace setting,
Right.
you need an exoskeleton that can keep up with the dynamic nature of the job.
Got it. So it's like having an invisible helping hand, not a robotic leg brace that dictates your every move.
Right.
That's a game changer for sure. But how did the researchers actually test this thing out? Did they just have people strap it on and walk around the lab?
They took it a step further than that.
Yeah.
They recruited 10 participants
Okay.
and designed a series of experiments to really put this exoskeleton through its paces.
Okay.
They wanted to see how it performed across a variety of tasks, from simple walking to more demanding activities like lifting and lowering weights.
I'm guessing they were also measuring muscle activity to see just how much effort the exoskeleton was taking off those quads, right?
Absolutely. They used EMG, or electromyography, which measures the electrical signals that muscles produce when they contract.
Okay.
This allowed them to compare muscle activity with and without the exoskeleton and see how much assistance it was providing. They also used a motion capture system to track movement patterns and a metabolic system to measure energy expenditure. So we're talking like a pretty comprehensive analysis.
Okay, so they had the tech, they had the test subjects, they were measuring everything.
Right.
Time to unleash the robot legs.
Yeah.
What did they have these folks actually do?
Well, they started with the basics, walking on different inclines,
Okay.
like ramps and stairs, to mimic real-world environments.
Okay.
Then they had them perform lifting and lowering tasks with varying weights, all while carefully monitoring their muscle activity and movement patterns.
Okay, but that sounds like a typical day for a lot of people.
Yeah.
How did they really push the limits and simulate those high fatigue scenarios that can lead to injuries?
So this is where it gets really interesting.
Okay.
They had the participants do a massive squat session with a kettlebell.
Okay.
And I'm not talking about a few reps here.
Right.
They pushed them to near exhaustion.
Oof. I'm wincing just thinking about it. Did they at least get a smoothie break after that?
I'm sure they got some well-deserved rest.
Okay.
But here's the crucial part. Immediately after this fatigue-inducing workout, they had them perform timed trials of those same lifting and lowering tasks, both with and without the exoskeleton's assistance.
Okay, so they had them squatting until their quads were screaming, then immediately put them to work to see how the exoskeleton held up under pressure.
Right.
This is how we separate the contenders from the pretenders in the robot leg world. Drumroll, please. What were the results?
The results were pretty remarkable.
Okay.
Across almost all tasks, the exoskeleton significantly reduced the amount of effort the quadriceps had to exert,
Okay.
even when the muscles were already fatigued. We're talking up to a 24% reduction in muscle activity
Wow.
during those walking and lifting tasks.
24%, that's huge. That's like having a quarter of your workload magically disappear.
Exactly. And it gets even more impressive when you look at the timed trials.
Okay.
Remember, these were conducted right after that grueling squat session.
Right.
The people wearing the exoskeleton were 43% faster in those post-fatigue trials.
43%. Okay, color me impressed. But speed isn't everything, right? You mentioned earlier that this research was also focused on preventing injuries.
Right.
What kind of impact did the exoskeleton have on the participants' posture and form, especially when they were tired?
Yeah, that's a crucial point. When we get tired, our form tends to suffer.
Right.
That's when injuries happen.
Mm-hmm.
In this study, they specifically looked at something called thorax lean,
Okay.
which is essentially how much you lean forward from your hips.
Okay, so imagine a plumb line dropping from your ear.
Right.
Ideally, it should line up with your ankle when you're standing upright.
Mm-hmm.
Thorax lean happens when you lean forward, and that line shifts forward, putting a ton of extra stress on your lower back.
Exactly. And the exoskeleton demonstrably helped participants maintain a more upright posture even when they were exhausted.
Okay.
This suggests that it could play a significant role in preventing those lower back injuries that are so common in physically demanding jobs.
Yep. So it helps you lift faster, reduces fatigue, and improves your posture. This is starting to sound less like a supportive exoskeleton and more like a superhero suit.
Right.
But let's get real for a second. How well does all of this lab-based research translate to the real world?
Oh.
I mean, labs are controlled environments.
You are right. Lab settings are very controlled.
Mm-hmm.
To address that, the researchers created a multi-terrain circuit for the participants to navigate,
Okay.
including ramps and stairs, which is much more representative of real-world workplaces, right?
For sure. Think construction sites, warehouses, even hospitals. All those environments where you're constantly on the move, navigating obstacles, and dealing with uneven terrain.
So did the exoskeleton fall apart once they took it out of the lab, or did it rise to the challenge?
It rose to the challenge. The exoskeleton adapted smoothly between tasks,
Okay.
and the participants generally reported finding it helpful, particularly when tackling the more physically demanding aspects of the course. Speaking of real-world applications, did the researchers happen to touch on comfort levels? I mean, wearing a robotic exoskeleton all day doesn't exactly sound like a walk in the park.
You've hit on a crucial point. While the source material doesn't explicitly use the word comfortable,
Okay.
we know participants wore and used the exoskeleton effectively across a variety of tasks, including that multi-terrain circuit.
Right.
And they gave positive feedback about its helpfulness.
So, reading between the lines, comfort likely wasn't a major barrier to its use.
Precisely. And remember, this is just one study, but it unveils exciting possibilities for wearable technology.
This deep dive has been really eye-opening. I'm already envisioning these exoskeletons on construction workers, nurses, firefighters, like anyone whose job demands serious physical exertion.
Yeah,
It could be a game changer for so many industries.
absolutely. And what's particularly fascinating is that this study honed in on the quadriceps.
Right.
But imagine the possibilities if we applied this technology to other parts of the body.
Okay, now you're speaking my language.
Yeah.
A full-body exoskeleton. Are we
Yeah.
talking about, like, creating a real-life Iron Man suit here?
Well, not quite Iron Man just yet,
Okay.
but we're definitely venturing into exciting territory. Imagine combining this type of knee exoskeleton with devices for the back, ankles, even the upper body.
Yeah.
We could create a system that provides comprehensive support, drastically reducing the risk of injuries across a whole range of movements and tasks.
Wow. We could be talking about a future where physically demanding jobs are no longer as physically demanding.
Right.
That could revolutionize entire industries, making them safer and more accessible.
Precisely. And let's not forget the potential applications beyond the workplace.
Right.
Imagine the impact this technology could have on people with mobility impairments.
Yeah.
This could be a pathway to helping them regain independence and engage more fully in their daily lives.
It's incredible to think we could be on the cusp of such a transformative breakthrough.
Yeah.
But I have to ask, were there any downsides or limitations to the technology uncovered in this study? Well, every innovation has its challenges.
Right.
While this particular study focused on the positive impacts,
Right.
it's essential to acknowledge that long-term reliance on exoskeletons could lead to muscle atrophy, if not implemented thoughtfully.
Oh.
Designing exercise regimens that complement the use of exoskeletons will be crucial. Additionally, while this exoskeleton showed impressive adaptability,
Right.
navigating truly unpredictable environments might present new challenges.
Okay.
Further research is needed to explore those areas.
Those are excellent points. It's like any tool, It has the potential for immense good, but needs to be used responsibly and thoughtfully.
Right.
We can't just slap on an exoskeleton and call it a day. We need to consider the long-term implications and potential drawbacks alongside the benefits.
Exactly. It highlights the importance of ongoing research in this field.
Yeah,
As we continue to refine this technology, we need to address those, like what ifs,
right.
and ensure that we're using it to enhance human potential without creating new problems.
So for our listeners who are now, like me, completely captivated by this technology,
Huh.
what's the key takeaway here? What's the one thing you hope they'll remember from this deep dive?
I think the biggest takeaway is that we're witnessing a paradigm shift in how we think about human strength and capability.
Mm,
It's not just about building bigger, stronger machines, but about designing intelligent systems that work in harmony with our bodies to improve our lives.
okay.
This research is a testament to that, and it's only the beginning.
What a fantastic way to wrap up this deep dive. It's not often we get to explore research that has the potential to be so profoundly transformative.
Right.
It's going to be incredibly exciting to see where this technology goes next. Until next time, keep exploring, keep asking questions, and never stop learning.